So, starting off, it says find f of 86, which means we're replacing the x into the function with the value 86. So it's the square root of 86 minus 5. 86 minus 5 is 81. Square root of 81 is plus or minus 9. Find the values of x for which it's undefined. We know if it's undefined and there are no values of x possible. Since the function is a square root function, we know that the expression within the square root has to be greater than or equal to 0. So we say x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5. They're the values that it is possible. So it would be undefined for values less than that. So in other words, x is less than 5 is the answer to this question. Here are two functions. We need to find the inverse function. Note that's indicated with a minus 1. So we write y equals 3x minus 5. Switch the x and the y. And then rearrange to make y the subject. So the inverse function is x plus 5 divided by 3. Given that g minus 1x is x plus 2, we need to find g minus 1 of f. So this indicates that f is going into the inverse function. So f was 3x minus 5. So in place of this x here, we're going to write 3x minus 5. So g minus 1 of fx is 3x minus 5 plus 2. Simplifying that gives 3x minus 3. Given also that we need to solve that this function is equal to this function. So they've given us an expression for this first one. We've established the second one, so we need to put those equal to each other. Oh, I haven't given myself much room. So x plus 3 over 3 equals 3x minus 3. We need to undo that, so it's x plus 3 equals 9x minus 9. Moving the x's to one side, numbers to the other, you get 12 equals 8x. X is 12 over 8, which is 3 over 2. Next one, we have to let hx equals fx over gx, and we're sketching the graph. So fx, so it's fx over gx, so 3x minus 5 over x minus 2. And literally we're just going to plug that into the calculator in y equals. And I'm going to enter it as a fraction, which is a little bit easier. So it's 3x, I forget 3x minus 5. Over x minus 3. Oh, x minus 2. And they've specifically asked for this range of values, so I'm going to change my view window before I enter it. So we're going from negative 3 to 7 on the x-axis. Oops. And we're going from negative 2 to 8 on the y. And then we just press graph. So literally we just copy that picture onto the diagram. We need to include any asymptotes. So hopefully you can see here that there's a horizontal and vertical asymptote. I guess I should copy this. Oops. I'm just going to snip it. Just to save a little bit of time. And so we can see there's a, oops. There's a vertical asymptote along here and a horizontal one there. We should probably give the equations of those. So the vertical one.
Because you know I'm all about that.
So we have the vertical equation is x equals 2, and the horizontal one would be y equals 3. Number 3, there's a diagram of a function. We need to sketch f of minus x. So because the negative value is inside the bracket, it means it's a reflection in the y-axis, which means that this whole graph is going to be reflected in this line here. So, oops. Oh. So it would look something like that. Okay. And it says let gx equals a half f for x minus 1. Point A32 is transformed. Find the coordinates of P. Okay, so first of all, the minus 1 in the brackets indicates a horizontal shift. Because it's minus 1, it's shifting to the right. So that first movement would mean that it's no longer at the point 32, but at the point 42. Then we've got a vertical stretch by scale factor of half, which affects the y coordinate instead of the x, and so the y coordinate is going to be halved, so our new coordinate is going to be 4, 1. So P would be the coordinates 4, 1.